Hi everybody, I'm Phil Fatica. Thank you for joining us here on Channel 9. It's the Mill Creek Government Channel. Our table today is set just for you to ask a lot of questions as to what these are. And the gentleman sitting next to me, Bill Kohler from Penndot, is going to be telling you what he's doing with this to benefit your driving experience. Bill, let's first of all say that you work for Penndot and your title is?
I'm the District Bridge Engineer.
District Bridge Engineer out of?
Oil City.
So you cover a large territory?
We take care of 6 counties in northwest Pennsylvania. 6
counties in northwestern PA. Okay, because man, have I got questions for you, because the bridges around where I live, they ain't doing well. And today we're talking about preserving and waterproofing those bridges, and everybody can tell you that, boy, the one I travel over, my car just gets beat up. And all across the Commonwealth, the bridges are collapsing and the infrastructure's this and it's that. How do you respond to those negative questions? Let's take a general one out there. How do you respond and say, you know, we're dancing as fast as we can, or where?
Actually, I started back in 1981 and started actually designing bridges in 1982. And we had actually come from probably, I think, the worst period of Penndot was in the late 70s. The Shap administration had a lot of indictments. There was money flowing places it shouldn't have flowed, and it wasn't being put on the roads. And we had roads that just had potholes everywhere. And I say that because I don't think this generation understands what a bad road is. I mean, back in the late 70s, we had bad roads. We had a reputation which...
the Commonwealth.
Commonwealth, or well, Penndot. Penndot was a swear word back then, and you really didn't want to associate yourself with the term Penndot back when I first started. In fact, in 1981, I actually manned a pothole hotline. Well, we had a pothole hotline for 10, 20 years, and it sort of morphed into a 1-800 fix roads, but people would call in daily and tell us about the bad potholes on their road. In the as we got funding in 1982, which was one of the first in the country, I believe, dedicated 4 bridges, that started us, I talk about my paper, a transformation of 30 years from a poor bridge system to one which we would regard as fair.
Fair, okay. And again, no discredit. Going from poor to fair is a huge leap. And you can go from fair to excellent if somebody just opened up all their wallets and said, hey, have a good time. Because you're always fighting for the dollar. There's no doubt about it. Let's talk about some of the materials that you have on the desk here as to how they're used in the preserving and the waterproofing of bridges. No denying, northwestern Pennsylvania has that freeze-thaw cycle. We get a lot of snow, and to combat that, you have to put chemicals on the roadway and the bridges. You see the sign that says bridge ices before roadway or things, all those kinds of things. And of course, you're directly to blame because you're not doing the job, keeping these up because, good grief, what is the matter with you? Can't you see that they're just crumbling and rusting? Speaking of rusting, let's start with that piece right there. That's a chunk of rust. And what do you do about it? Do you call somebody in and say, we're going to sandblast this and we're going to put in some Bondo and you're good to go?
Well, it would be nice to be able to do that, but in our business, that's what we want to avoid.
You want to avoid this.
Right.
And how do you avoid that?
Well, one of the things, and a good example is the project we're doing out on 531.
That was the Depot Road, Harbor Creek.
Right.
Okay.
A lot in the late 50s, the engineers at that time had never built a bridge system or an interstate system.
Right. Eisenhower started that.
Right. And there's a lot of new technology out there. One of them was pre-stressed beams, which are basically a concrete box they're hollow on the inside, and they have high-strength strands on the bottom. They used to make them out here at Top Rock.
Oh, sure. Remember that?
Pull those strands up really tight. Concrete sets up. You let them go. The beam gets a nice haunch to it, which you can still see, and it's strong, and it doesn't rust, and it spans a long span. But the problem they did is, in a lot of these bridges, they just had an open joint. Or they would put this in here.
We want to leave that right there. Just point to it. Yeah.
Which is a neoprene.
This right here.
Yeah, it's a neoprene compression seal. The problem with neoprene is once it compresses, The guy told me neoprene cures its whole life. So if it stays in that position any length of time, it's going to cure like that and not want to come back. And we just replaced one of these on Interchange Road next to the mall because it fell out. So when those leak and fall out, then that salt and water gets down on the pier cap, or it gets down on the steel girders and starts them to rust.
Okay, and how long does it take to get to this point here? Does that take months, years?
That would probably take years. It all depends on the amount of salt and water that are getting on it.
Speaking of salt, there it is right there.
That's right.
Okay, that is what you call a...
Well, I have my own term. I call it an epitite because usually it's hanging down from the bottom of a bridge, just like a stalactite.
Right.
But it's when salt and water goes down through the bridge deck or pier cap or whatever concrete, it pulls the lime out, makes a hard chemical like that, that once it precipitates or dries, it forms a stalactite underneath the bridge. And it's actually the concrete is absorbing chloride, and once you get too much chloride in there, then the concrete just crumbles. And people can see that on some of these older bridges. The parapets are just crumbling apart. Part of that is due to the salt, but part of it is back in the 50s, again, they didn't realize that there's a lot of water trapped in concrete because in order to make it work and work it and finish it, you actually put more water in there than is chemically needed to react it. So that water stays in there, and if you don't provide a place for that water to go when it freezes, it will spall the surface. So we have what we call entrained air, and it's tiny little air bubbles that they put in the matrix of the concrete so that water has a place to go. Okay. So if you see a poorly finished sidewalk, the guy will have worked it too much, and he'll have worked all the air out of it, and that's why it scales off the first year. Okay. Same process.
Now, I should say, in defense of what you do, in defense of Penndot, that this is a problem throughout the country, that the bridges, the infrastructures. Is it we just never allowed monies to keep them up, or it's just because they've become so expensive to keep up? I mean, let's talk about 531 and Depot Road. What's the price tag on that? Could I give you some money to help you out a little bit, you think, if I had how many millions?
Well, I think it's on your cheat sheet there.
No, I didn't get that on my cheat sheet. No, but you tell me how much.
Well, I believe it's what we're spending is 1.5 or 2 million on there.
Okay.
And the advantage of that is, and we are to spend that kind of money on that bridge and get another 30 or 40 years out of it, and we may get a lot longer out of that investment if we didn't do that today. And that's been on my radar for many years. If we don't do it today and we keep patching it like we've been doing in the past, that bridge will eventually get to the point where we would actually have to replace it.
Okay. And so then you're talking more than $1.5 million.
Now we're talking $5 to $10 million, at least.
And you're right. I'm glad you mentioned that, because what makes these repairs are going to put another 30 years on that bridge.
At least.
At least. Okay. So we got the rust, we got the salt, we got a rebar that's
epoxy coated,
which
keeps it from rusting. It's it's a coating.
You have the
neoprene
there, which is compression and doesn't come back. And then what is this? This is
before I get to that,
solid.
let me get to this, because there's a natural progression between here and here.
Okay.
This, because it failed and would fall out eventually, somebody came up with the idea, and you can see this on the I-79 bridge over Conrail and 16th Street out there. They took this and added little tabs onto it so it would hold it in place. Well, then somebody said, well, if we're going to do that, why don't we just make a strip? So somebody came up with this. This is a strip seal.
This right here.
Yeah, so this is embedded in concrete. Trucks can go over it, and of course a bump, it pounds really hard on both sides. So this is why this is heavily reinforced and tied in the concrete deck. But it allows it to move in and out. And it's held solidly right here, so this will not fall out in the future, and we've had really good success with them staying in place and sealing any water from getting underneath.
These semis that roll through, if they're loaded, totally, what kind of weight are we looking at on there?
Well, that's the other half. When engineers in the 50s looked at this interstate system. The railroads were really strong and still carrying a lot of freight.
Right.
Well, the interstate system comes along. If you look at the original plans, a lot of these were only designed for 5% trucks. Now we have 10 times that amount of trucks, and your trucks have gone to 74,000 to now they're 80,000. And what most people see but don't realize is a lot of these overloads that you see that are police escorted, some of those are normally are running through our system at 3, 4, 500,000 pounds on a
truck.
On a truck, yeah. Now,
not a railroad
normally
car.
A 500,000 pounder is pretty unusual, but I remember years ago we had a mirror that came into the docks here, and it had to go down to Butler.
I remember that.
To be polished. Well, we allowed we gave them a permit to run I-79 at a crawl speed over the bridge. Well, it was sort of, and that would have reduced the amount of impact on the bridge. Well, it was sort of funny. The next day they talked in the news about how they made record time at 45 miles an hour down to Butler.
Okay.
So, and that thing I think was 300,000 or 400,000 pounds, and those used to be rare in the 80s. Now they're every week.
Okay. Okay.
So not only are we up to 80,000 pounds, we're getting way beyond that on a regular basis.
Why?
Why? American industry, containerized things that are fabricated in one shop under one set of controls. You avoid field welding, so a lot of these things are press boxes, huge, like that mirror needed special place to be polished. It's easier. Okay. And a lot of this stuff is coming over from foreign places where they're fabricating it, bringing it into the docks in Erie or someplace and pulling it off and putting it on a trailer, because your rail system could handle the load, but they're usually too wide for track. For track,
okay.
So it has to go by.
So we've gone there and there, and now are we here?
Now back there, that's what your beams sit on.
Move that a little bit there.
And back in the 50s and 60s, a lot of the bridges were built on what they called a metal sliding plate, just two plates that slid, or they could be on rockers, and we still have a lot of those out there. The problem with those is in earthquake zone, rockers aren't good, and besides they rust and eventually can lock up. So they came out with neoprene, and neoprene is really good because it's impervious to salt and water. The problem is, a big hunk of it like itself, if you put a lot of load on it, it would just squish out. And then when you moved it back and forth with temperature and forces, and then it would just fail. So and that one, you'll see in the center of it, it's reinforced with steel sheets. Okay. So that allows it to actually tip over at almost a 45 degree, go back 45 degree the opposite way and come back, and no deterioration or failure of it.
Okay. Now, there's a small piece that you have right in the middle. I'm going to point it out so Daryl knows where I'm pointing right there. That is for what?
Now that's what we're putting on the I-90 over 531 bridges, and we have it out here on 14 bridges on Peach Street, from Peach Street to 430. All those bridge decks have this as epoxy overlay. And what that is we shot blast the deck, we get it a rough surface, get off all the dirt, and they come in and just pour liquid epoxy on the deck, and they squeeze it around, and they put a really hard flint on there. It's not something you want to fall on your motorcycle.
Right there, yeah, that would hurt. I had 3 bikes and I've fallen, and that hurts.
So that provides an impervious, hard surface to keep salt and water out, and provides a good traction also. So
when you're talking about these very highly traveled, let's take Interstate 90 for example, and they count the cars. I know it's tough, but a high number of cars, trucks going across a certain bridge in a certain month or a certain time. What is what? How many of them going back and forth?
The more traveled sections of I-90, I believe, are running around 25 to 30,000 vehicles a day.
A day. That's a 24-hour.
And that would be 40 to 50% of those would be trucks.
Okay. So, and you're talking a truck that's pulling how many tons?
40 tons.
40 tons. 40 tons. Doesn't take long to wear them out.
No.
Beat them up.
That's right.
Yeah. Generally speaking then, how do you look at a bridge and then measure the health of that bridge and say, we're okay here, but boy, that's just not working at all. And this, well, we might be able to live with that. Is that what you do? You come in and assess it?
Right.
Okay. Do you ever have to get down underneath it anyhow, hang from, look at, and okay, and then what do? You come back and you say, gentlemen, here's what we have to do.
Right. So by law, we have to go out and inspect every bridge every 2 years. If the bridge has deteriorated to a point, we will go out and inspect it more frequently. Typically, you might see, as far as hanging over the side of a bridge on 6 Mile Creek or many of these other ones, we have an elbow crane that gets down underneath and you can look at the bridge.
Yeah.
The good thing that's happened is a lot of, like 6 Mile Creek last year was basically a 2-girder bridge. So, and it's similar to the one in Minnesota that collapsed.
Yes.
One of the members failed. It's only got 2 supports. This one went down, the whole thing falls in the creek. Now it has 5 girders in the cross section, and if one fails, you got 4 others. So we call it redundant. So a lot of our bridges are a lot safer and maintenance free. And so basically when we go out, it's a scale of 0 to 9. We look at the supporting members, which we call the substructure. That would be your piers and your abutments. And we also give a 0 to 9 rating to your beams, and then a 0 to 9 rating to your deck.
Okay.
So our inspectors go out and they look at that and they assess that, and then it comes back to me.
And generally speaking then, overall, the health of the bridges in Erie County is on life support?
Well, they're like the rest
better
of them.
call in the doctor, or hey, you're good to go.
Now I would say
depending,
they're middle-aged. They're
middle-aged,
fair.
yeah.
They're in fair condition.
Which leads to my next obvious question, which we touched on earlier. How do you get the money to repair these? Where does the money come from?
Well, we enjoyed a real spike in money in the last couple of years due to the president's ARA money, and then also the state also floated $300 million worth of bond money for a while, and then they were going to toll the interstate, and they were taking money taking money from the turnpike was advanced payments. So those 3 sources plus what we normally get from gas tax and registration fees all go into the capital side, and we actually increased our program by about 50% or more. So we've been enjoying a high level of funding, and if we could continue that level of funding for probably another 10 years, we would probably fix the whole bridge problem. My goal is to get our bridge system to where you have minor deterioration, minimize deterioration. Then we could take that money and fix the local system, which is in really poor shape.
Yeah.
And it keeps getting worse because there isn't a lot of funding for local bridges. And then we could also invest in the highway side. So my goal is to eventually get to the point where we're not spending as much money on bridges because they're self-cleaning and they don't deteriorate.
Pittsburgh prides itself on the number of bridges they have crossing everybody. We have more than I thought we did. I don't know why. I just don't think of it as being like that. And in the city, I'm trying to think, yeah, they're there, but I just don't notice them, I guess. But now that you're talking and you're mentioning these places, and in my mind I'm saying, oh yeah, I know where that is. Oh yes, I know where that is. And I'm thinking to myself, if you could design this perfect bridge, where's the design heading? We've gone from there to here, we're now there. What's the next step that people are going to come up with and say, we're going to get 40 years out of this now. We're not going to get 22, or we're going to get better, warmer climates. We might get 60 years out of this. I don't know. Are you part of that process?
Yes, actually, we're designing bridges for 100 years now, at least. And you can see that, the 26th Street interchange. Next time you go underneath it, look at the pier caps and the columns where it's continuous steel, there's no joints.
26th and?
I-79.
I-79.
26 goes to I-70. Those spans are in good shape. They're just not exposed to salt and water. Yep. So the key is keeping our bridges from getting exposed to salt and water. And if we do that, we can reduce the deterioration rate to a very minor amount. And like I said, so I believe we're already there. The next frontier for engineering is composites carbon fibers, things like that, which make beams really lightweight. Maybe the whole progression, if you look at it, like on a good example is Peach Street, I-90 over Peach Street. That used to be a 3-span bridge. Now it's 1 span.
1 span, yeah.
So our steels and our concretes are allowing us to span farther, less substructure units. The neatest innovation for us is where you just drive 1 row of piles, put your beams on top, and you tie all that together, and any of the expansion is taken up into piles.
Okay.
So there's no joints. So we're trying to get away from joints. We're trying to make our spans longer, and that integral abutment bridge is allowing us to reduce our costs by 20 to 40%. So we're trying to make bridges maintenance-free and last at least 100 years.
That's an amazing number. 100 years. That's, yeah. That really makes me sit up and say, "Holy smokes!" You know, we live here, and I think we're at a distinct disadvantage, and even perhaps Pittsburgh, and certainly Center County or Dauphin County or Bucks County as we start moving into a much milder climate. Is that true? Is it really we do suffer the brunt of most of this, and these other people seem to get more life out of more bang for their buck because their weather's a little gentler? Or is it an equal opportunity offender and it takes care of everybody? No,
you're correct. The Great Lakes, if you look at the Great Lakes, sometime if you're on a weather channel in this winter, an Arctic blast comes down from Canada, you will see that the warm water shield our area from that cold weather. On the other hand, cold weather moving across there picks up moisture and gives us the snow that we have. So on one hand, we get a more temperate climate, but that brings us more freeze-thaw cycles. It also brings us more water. So we generally, our snowstorms to a large extent don't have the amount of snow that you would in Philadelphia. Philadelphia gets 30 inches of snow a year.
Right.
They get several cold northeasters coming up. It dumps snow. They shut everything down because they don't have snow plows.
Correct.
To plow everything. Everybody stays home. The sun comes out, melts it the next day, they're happy.
Right. Life is good.
We up here are spreading anywhere from 100 to 150 days, either spreading or plowing and it could only be a half an inch or an inch of snow, but it's spread out over 24 hours and you still have to put down salt.
Oh, sure.
So many times our guys are out there spreading salt and they're not really plowing a lot of snow. So we do have the harshest climate, I believe, as far as the amount of moisture we get and the amount of salt that we have to deal with.
One of the bridges that goes over 79 says spraying in effect, or you know what I'm talking about?
Right.
The things pop up and they spray it. Does that cause, or is that better than salting? Is there an agent in there that gets rid of the slipperiness but doesn't cause the deterioration?
Now, that chemicals that they have that would be benign as far as rusting the cars are really, really expensive. So we still use materials that will rust a car out, but on that particular bridge, it would tend to freeze before the surrounding roadway, so we've been able to reduce the amount of accidents on that bridge. Due to that spray system.
This is Bill Kohler again, and Bill is with Penndot. He is the district bridge engineer for, again, which district?
District 1.
District 1, which is where we live. And all of this is what goes into making you drive safely over a bridge. Bill, I learned a great deal today, and you explained it clearly and succinctly, and thanks for saying that the bridges here are going to be around for a long time, but that's because of good people like you that really know what you're doing. I appreciate you coming here.
Well, thank you
so very much. This is very, very interesting to me, and I'm sure it was interesting to you too. Thanks for being with us. Until next time, I'm Phil Fatica. Take care.